Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 12.3, Problem 10. This is Section 12.3, problem number 10. It says find the derivative of f of x equals, and what you have is a fraction in parentheses raised to the power. You have 6x over 2x minus 1, all in parentheses raised to the fourth power. So overall, what we have is some stuff in parentheses to a power, so we can apply our chain rule. Our function is some stuff in parentheses to a power. So we will follow the formula of f prime of x. The end, the exponent is going to come down in front of the stuff. You leave the stuff the same initially, reduce the power by 1, and then multiply times stuff prime. Now, when we get to the stuff prime, the stuff is actually a quotient, right? It has a top and a bottom. So this is from the previous section from 12.2. So again, the top of this quotient would typically be represented with a u. The 6x would be equal to u. The denominator of the quotient, the 2x minus 1, is represented with a v. So when we get to that stuff prime, what I'm really going to wind up doing, let me write it one more line. F prime of x is n times stuff to the n minus 1. Now my stuff prime, to find the derivative of the stuff, I'm going to use the quotient rule, which is vu prime minus uv prime over v squared. So this kind of combines the quotient rule with the chain rule. So let's fill it in. F prime of x equals, the n comes down in front. Now my n for this one, the exponent, is 4. So we start with a 4. Put some parentheses, and leave the stuff the way it is initially. So the stuff, again, is a quotient, a division of fraction. The top or numerator of my fraction is a 6x. And the denominator of the fraction is a 2x minus 1. That stays exactly the way it is. I make a new exponent for that fraction, which is n minus 1, which for this problem is 4 minus 1, which will be 3. And then times the stuff prime. And again, to find stuff prime, I need to apply the quotient rule, because the stuff really is a quotient. It's a fraction with a top and a bottom. So the first part of my quotient rule is v, as in the bottom. No prime, just v, so just 2x minus 1. Times u prime. So now u is the top, 6x. U prime is the derivative of 6x, or just 6. And again, when you take the derivative of something that just has an x to the first power, the derivative is the number in front of the x, which in this case is 6. Now I have minus. Then u, no prime, just u, so u with no prime is 6x. Times v prime. So v is the denominator, 2x minus 1. V prime will just be 2. Again, the 2x has a derivative of 2. It's an x to the first. The derivative is the number in front. The minus 1 has no x, so its derivative is 0. So the derivative of 2x minus 1, again, is just 2 for the v prime part of my quotient rule. And underneath, you have v squared. No prime, just v squared. So 2x minus 1 is the v. So I put 2x minus 1 in the denominator, put some parentheses on it, and raise it to the second power. Now again, this is the answer. If you like, you can simplify it. At this point, it's good. Like if you need to, you can start putting in values for x and simplifying it. But the quotient rule portion here is simple enough. I can clean it up a little bit. F prime of x equals, so I'll leave that 4 in front, and I'll have times a fraction 6x cubed, 6x over 2x minus 1, all in parentheses cubed. Notice you cannot bring the 4 in and multiply it times the 6, because the 6x in the top is raised to the third power, the 4 is not. You must do your exponents before you multiply. That's that please excuse my dear Aunt Sally rule of order of operation. So the 4 has to stay outside. And now, this quotient rule part of it that I have on the right-hand side in the top of my quotient rule, it starts with 2x minus 1 in parentheses times 6. So I can distribute the 6 through the parentheses. 6 times 2x is 12x. Then 6 times minus 1 is minus 6. And then I have, after the minus sign in the top of my quotient rule here, 6x times 2. So that's 12x. Because 6x times 2 is 12x. Don't forget there's a minus in front of it. And I will leave the 2x minus 1 to the second power underneath. And now I have positive 12x, negative 12x. And I can keep that in parentheses just to make it clear that I'm multiplying times everything else. So I'm left with a minus 6 in the numerator times a 4 in front. So I can make that. Minus 6 times 4 is negative 24. So f prime of x, I'll have a negative 24 to start off. That takes care of the 4. That takes care of the minus 6 that I had in top. And now it can be times 6x cubed on top. Now in the denominator, if you want to, you don't have to simplify it this far, but if you like, you have a 2x minus 1 raised to the third power and a 2x minus 1 raised to the second power. So if I combine those two things, I would add the exponents. When you have the same base and you multiply, you add the exponents. So third power plus second power, I would have in the parentheses underneath 2x minus 1 in parentheses to the fifth power, again from third power plus second power. So that's about as simplified as you would get. And you don't have to simplify it that much, but if you like to clean it up, you'd have a final simplified answer of f prime of x equals negative 24 times 6x in parentheses to the third power over 2x minus 1 in parentheses to the fifth power.